Alright, this video is about quadratic inequalities, and we're going to be solving quadratic inequalities by graphing, and we're also going to be solving them using algebra. Many business profits can be modeled by quadratic functions. To ensure that a profit is above a certain level, financial planners need to graph it and solve quadratic inequalities. A quadratic inequality in two variables can be written in the following form, where a, b, and c are real numbers, and a cannot be 0. So some of the forms it can be written in, this is standard form for a quadratic, right? Ax squared plus bx plus c. And you can see that instead of an equal sign, we have these various inequalities, less than or equal to, greater than or equal to. All right, so to graph these, to graph a quadratic inequality, the first thing you're going to do is graph the parabola that defines the boundary. So first you're going to graph the parabola. Then, as you're graphing it, you have to use a solid line. Okay, first you're going to graph the parabola. Now, when you're graphing the parabola, a couple of reminders about how to do that. We know the axis of symmetry is at x equals negative b over 2a. Okay, and you can find the vertex by plugging that x value back in. You can also find the zeros to help you graph it. Find the zeros by factoring or just by doing the quadratic equation. Okay, and you can graph it on your calculator and use a t-table or plugging in values to form your own t-table in order to graph it. Okay, so once you have it graphed, then when you're going to draw it on your paper, if it has a less than or equal to, or greater than or equal to, then you need to draw the actual line. But if there is not a line underneath it, if it's not equal to, if it's just less than or greater than, then don't include that actual boundary line. You need to make it dashed. So for less than or for greater than, we just draw a dashed line. All right, and then the third step is to shade. So you're going to shade above the parabola for y is greater than or y is greater than equal to, and you're going to shade below the parabola for y is less than or y is less than or equal to. And I've put a couple pictures here. Here you can see above the parabola if the parabola is facing downward, and above the parabola is on the inside if the parabola is facing upward. So either way, you're going to go either above or below if the inequality is greater than or less than. So let's do an example of this. Graphing inequalities in two variables. Here, let's see if we can graph this function. So first we're going to have to graph it, graph the boundary, and when we get ready to graph this, we can see from the function here that the y-intercept is 10, and I used to use a calculator to graph this, and I got the vertex, and I also got the y-intercepts by factoring, so 2 and 5. So here's the parabola as we graphed it. Notice that we have a solid line because it says that y is greater than or equal to. And since it has greater than, I need to shade above the parabola, so I'm going to shade inside here. Okay, good. We can check our answer by using a test point to see whether or not the answer will be, when we plug in, so let's see, let's pick a point. So if I go back to the graph here, I can pick a point inside the parabola. Okay, that's where I ended up shading. So picking a random point inside here, we're picking the point 40 right here inside the parabola. So, okay, when we plug in 4 for x, what do we get? When we plug in 4, we get negative 2. And since negative 2 is less than 0, okay, that means that it has worked and we have the correct answer. Quadratic inequalities in one variable, such as ax squared plus bx plus c is greater than 0, have solutions in one variable that are graphed on a number line. So we can graph our solutions on a number line. Now remember, for AND statements, both conditions must be true, but for OR statements, at least one of them will be true. So let's see if we can graph this one, and we are going to use a graph to graph our final answer. So let's see. First of all, let's go ahead and graph it using a graphing calculator to graph each side of the inequality. Okay, so first I'm going to graph y equals x squared plus 8x plus 20. Okay, I'm going to put that in my y1. Set y1 equal to the one side of the inequality. And then on the other side of the inequality, I'm going to put the right side here, x equals, or y equals 5. See that when I graph that, I'm going to have the line y equals 5 as well as the parabola. Now I can just see if I can find the place where the parabola is greater than or equal to 5. So I want to identify values of x for which the parabola is greater. And the parabola is greater than 5 on the places that I've colored in here in red. That's where the parabola is greater than 5. So if you look at the t-table for that, that's all the values. So let's see, that starts right here at negative 5. So it's going to be everything less than negative 5, and right here is negative 3. So we want the values that are greater than negative 3. So we can graph those two things on a number line. The parabola is at or above the line when x is less than or equal to negative 5 or greater than or equal to negative 3. So the solution set is x is less than negative 5 or greater than or equal to negative 3. So we can graph that on a number line. So remember we use colored in dots, a shaded in dot at negative 5 and less than that, and then a shaded in dot at negative 3 and greater than that. Let's do one more that's just like that. Okay. Okay, this is the same problem actually. Let's see if we can do it. What if they ask us, instead of finding when the parabola is greater than or equal to, where is the parabola less than or equal to 5? So again, we're going to set the same values on our calculator as far as how we enter it in. And this time we want where is the parabola less than 5. So it's less than 5 here, and that is going between negative 5 on one side and negative 3 on the other. So now when we graph it on our number line, we have greater than negative 3, sorry, less than negative 3 and greater than negative 5. So we're only coloring in the area in between them, and our dots this time are open because it's the points themselves are not included. Okay. The number lines show, this is a solution set for example 2, and so we can see that the solution, no matter if we're talking about greater than or less than, is divided into the three areas. The number line has been divided into three sections by the points negative 5 and negative 3. Those points are called critical values. And by finding the critical values, you can solve quadratic inequalities graph algebraically. So we can do this algebraically if we simply find those critical values, and then we can graph them on the number line. So let's see if we can do this one algebraically. To solve the inequality, x squared minus 10x plus 18 is less than or equal to negative 3 by using algebra. So to do this algebraically, first we are going to write this instead of an inequality as an equation. So an equation means I change it to an equal sign. Now I can solve this in the same manner that we were doing last unit. Go ahead and make it equal to 0. Solve the equation for x. Okay, so make it equal to 0, write in standard form, and then we're going to factor this. Okay, I'm going to factor this by saying what times what equals 21. What multiplies to 21 that will add to negative 10. So that's negative 3 times negative 7 would make positive 21, and negative 3 plus negative 7 would make negative 10. So now I can put each factor equal to 0 separately. Okay, and I can solve, and I get x equals 3 and 7. So that means that 3 and 7 are my critical points, or my critical values. These critical values divide the number line into three intervals. We have the things that are less than negative 3, or sorry, we have the things that are less than 3, we have the things that are between 3 and 7, and we have the things that are greater than 7. So looking at it on a number line, we can see that the two critical values at 3 and 7 divide the line. We have the things that are less over here, we have the things that are between in here, and we have the things that are greater than over here. What we have to do is test a value in each of these sections, okay, and see whether or not it will work for our function. So now that we have our critical values, we have to test points that fall into each section of the number line to see whether or not they work. So let's try 2 first. When we plug in 2, do we get a value that is less than or equal to -3? And no, we don't. Okay, let's try a value in the middle here. Let's just randomly pick. You can pick any value you want. I'm going to plug in 4. Okay, when I plug in 4, do I get a value that is less than or equal to -3? Yes, I do. Okay, what about when I plug in a value over here, a value greater than 7? So we'll plug in 8. When I plug in 8 to the equation, do I get a value that's less than or equal to -3? No, I don't. So that means that the only answers are the answers that fall in the middle here between 3 and 7. So the solution, we can shade the solution regions on the number line using a solid circle for critical values because the inequality contains them. So the solution set is between 3 and 7, and we write it like this. It's a compound inequality. 3 is less than or equal to x is less than or equal to 7. Okay, or we could write it in set solution, x is between 3 and 7. Good. One more like that. Let's solve this next one using algebra as well. So to use algebra, first we have to replace the inequality with an equal sign, okay, and we're going to solve the equation. So we're going to solve it by first subtracting, moving the value over so that it equals 0. Then we're going to factor it, okay, and put each, so we're going to factor it. 8 is 2 times 4, and we need to have a -2 and a -4, so it will add to -6. Then we're going to put each part equal to 0, and our critical values now are going to be 2, +2, and +4. So we've got our critical points of +2 and +4. Those 2 points divide the number line into 3 spots. So if we look at the number line, okay, when we put 2 and 4 on the number line, we have the values that are less than 2, the values that are between 2 and 4, and the values that are greater than 4. So we have to test a value in each of these sections. So when we test a value, when we try 1, okay, when we plug in 1, do we get a value that is greater than or equal to 2? And yes, that one happens to work. When we plug in 3, do we get a value that is greater than or equal to 2? No, that one doesn't work. And when we plug in 5, we get a value that does work. So that means that our answer has 2 areas that work. Okay, x can be less than 2, or it could be greater than 4. So this area works. This area does not work. This area does work. So when we shade this in, we can shade in correspondingly, and the solution is x is less than or equal to 2, or x is greater than or equal to 4.